Welcome back. We're going to continue our discussion. If you see that there's a pattern going on, when I first started with aldehyde and ketone, the video length was about 8 minutes. And then as I went to the halogen, I think it's slightly lesser. And you will see that this will be even lesser because it's always difficult to get the first thing out. Once that point, I think things will start to become a little faster. Just for me, and probably the same for you, because getting the whole idea of functional groups, numbering and everything, it all seemed like a huge thing first up, and then as you do just a couple more, it becomes so natural and easier. And I can see that myself too as I'm recording this video. Okay, alcohols, well, they all end with OL. If it is only one functional group, again, I repeat, we're not learning two functional groups in a compound yet. That's for later. All right, and I've told you actually. Now, as I said, oxygen can exist as one double bond or two single bonds. And if you apply this with the formulae, like how we've been doing, this is the formulae, and then with oxygen, we don't add or remove anything, which indicates there's 0 double bonds, right? Now, and we have learned that, right? Oxygen, if it is two single bonds, if it is outside, then one bond is attached to the chain, the other has to be a hydrogen, right? So if we drew 1, 2, 3, 4, 5, and 6, see if the oxygen is at the end, then one bond is already connected to this carbon in the chain, the other has to be a hydrogen. Okay, so I'm going to write this now as onto, this is, I just drew that to explain my point. 1, 3, 4, 4, 5, and 6. I'm just going to write it this way because it's the carbon. Or you can have 1, 2, 3, 4, 5, 6. You can have it in the middle. We've done this, we took so much care in learning this separately as a component on its own. Okay, or let's do actually 5 as we've been doing. 1, 2, 3, 4, 5. And let's say we do this. Okay, or actually let's put the OH over here. Okay, just make your life a little easier. All right, so as with any other case, you start numbering from the side closer to the end containing the functional group. So it'll be 1, 2, 3, 4, 5, and 6. And that's hexane, so it's hexane. That's your chain, but then we get rid of the E and write OL, so it's hexanol. Okay, hexanol. So that's what I did, right? Replace the E with an OL. But where is it located? It's in the first place. So 1-hexanol. Again, here you start numbering from the side that's closer to the side containing the functional group. So 5 and 6. Again, it's hexane. You replace, it's an alcohol, so you replace the E by a OL. Where is it located? It's in the second spot. So 2-hexanol. Let's keep going. Again, it's a hexanol because it's an alcohol group. But where is it located? It starts from the side that's closer to the end containing the functional group. So it's 3, 4, 5, and 6. So it's 3-hexanol. Here we have 5 carbons, so it's pentanol for sure, right? Pentanol, but we have alcohol, we also have a methyl group, right? So the alcohol group, well, again, you start from the side closer to the functional group, so which is why I moved it from here just to avoid that confusion. So it's 2-pentanol, right? But then we also have a methyl group in the 4th place, so 4-methyl 2-pentanol. And that's it. So basically your alcohol, in this case, there's no first or last name. It's both first and last, if you want to call it that way. Here, this is the last name, and this is the first name. I think I've repeatedly said your substituents are always your first name, but in this case, your alcohol is also another substituent, but because it's a functional group, it gets priority. Hence, the substituent is part of the last name, but the methyl group is part of the first name. And that's all I have to say on alcohol. Again, we can do 2,000 examples, okay? That's not the point. So let me leave you with maybe an example to do. So C6H18O. Okay, draw at least 4 isomers, okay, of alcohol, okay, and also name them. Well, that's it. I'll see you with another video.